Welcome back. So let's go ahead and talk a little bit about type string. It represents a flexible and dynamic expansion of C-like strings, so C strings that we have learned before. That you can take that as an example. This is a very important type since it is used in almost all the programming languages out there. So the concept that you learn here do not necessarily only apply to C++, but pretty much to all the programming languages out there. Anyway, the first thing that we will need to do, as before with all of these, I'm just going to type in include string. And down below, we're going to go ahead and take a look at what string actually is. So first of all, we need to declare and initialize these standard things. This string, I don't know, let's go ahead and use string s1 equals. You can see in some examples, strings are usually referred to with variables str or something like that. But for the sake of this demo, I'm just going to type in s1 equals how is it going? Or let's keep it simple. Hey, we'll leave it like that. And then we can, of course, print this out onto the screen. So just type in cout. I think you can actually see where this is going. It's fairly similar. And L. And yep, there you go. So this will simply be printed out onto the screen. Yeah, hey. You can put some text here, and then that text can be processed as a string pretty much anywhere else in the code. Okay, so you can also declare a string object, which is basically you can have more than one word. As you saw here with S1, you can have there you saw one word. But if we go ahead and create S2, for example, and say, hey, how is it going? You can have an entire sentence here. In fact, you can have an entire like text or whatever you want. You can write pretty much whatever you want to write. And you can, I don't know, it can also be played. You can also do this. This would be constructor initialization. And let's be lazy again and utilize this. So this is going to be S2. Let's print it out again. Hey, how is it going? But then again, you would achieve the same result without these. So you wouldn't have any problems there either. You see, hi, hey, how is it going? So no worries there. Let me just bring these back. Okay, you are also entitled, it is completely legal in C++ to declare an empty string. So std string s3. That's it. Do nothing else. This is the same as string s4 equals, this is empty. This is also an empty string. These two concepts are exactly the same. You are declaring an empty string, nothing else. Okay, let's go ahead and see the length of a string. If you can use the dot size that will return the length of a string. So signed int. Why are we using unsigned? Well, let me ask you something. Can a size of an array or a string be negative? Can it be negative? I mean, you can have a certain amount of elements or you can have no elements, but there is no way that the size can be negative. So why declare an int when it cannot be negative? Just use unsigned int s1 underline size, give it some arbitrary name here, and we can type in s1 dot size. So what is the size of s1? Think about it. Well, just count the letters in it. Okay. Oh, I didn't print it. My notes ran away from me. Okay, so they've just had it. They no longer wish to like socialize with me. Anyway, let's go ahead and print out the size of S1. So S1 underline size, and print that out onto the screen. It's 3. So H1, E2, and Y3. So 1, 2, 3. There are 3 elements. Again, the indexing was the same as before. No, nothing new about that. So you have 3 elements. You just count them 1, 2, 3. Basically, you just count the letters. It's 1, 2, 3, etc. You can just count them as they are. Basically, just counting the letters in a word or in a sentence But hey, how many? Wait, let me just reform this. Hey, T. What is the size of the array? What is the size of this string now? Does the space count or not? Is the size 4 or is it 5? Let's have a look. Shall we? It's 5. The space does count. Keep that in mind. So you're not only counting letters, you're counting pretty much everything that is in the string, spaces included. Okay, there is also a method .empty. Basically just checking if it's empty or not. We can just type in bool emp equals s1 dot empty. You can create outputs below this one and see if it's empty or not. You can use an if statement, like if emp is, for example, true, then print true. If it's false, then print false. Or if it's true, yeah, that's how you I'm just not creating the printouts below it, but it doesn't really matter. You can create printouts on your own. I'm pretty sure that you know how to do that by now. In any case, this is basically checking whether the string is empty or not. Okay, to access a certain character in a string, just as before with vectors and all the other and vectors and deques and arrays, it's the same. I mean, there literally is very little difference. So we just type in char, I don't know, C1 equals S1. So you have this fashion, which is not the recommended one, and we can type in 0. And down below, we can go ahead and type in. We can use the recommended way of fetching things from a string or from a vector or from a deque. So it's just char C2 equals S1 dot at, let's say 0. So let's just make them completely the same. And we can go ahead and copy this. Let's just go ahead and create a printout here. So it's going to be C1. And I'm going to create a space here. It shall be C2. H. Hey, what did I do? Right, okay. Do you see what I did? I didn't do anything wrong, but it says S1 at 0 and S1 index 0 here and S1 dot at 0. So we are accessing 2 same elements. It's capital H and capital H, the beginning, the first element of the string. Anyway, we can also compare strings. So you can check whether the 2 sentences are the same. Or, hey, you know what you can do? You can load the contents of a text file into a string, and then you can load the contents of another text file into another string, and you can compare the 2 strings, and you can have the program actually print out onto the screen like, hey, these are the differences between the files. Or it can just say the files are different or the files are the same. So let's go ahead and have a look at that. You can just do this S1 equals S2. So we're not going to actually do anything. I'm just showing you how you can do the comparisons. Obviously, you could place a body here and you could pretty much do whatever you wanted in one case and whatever you wanted in another. But I just want to show you that these operators do apply for strings. So you can s2 not equal to s1. And these conditions here can be evaluated, and then later on they can be utilized, as I've given you one example. And you can also do this. So s1 equals, and you can give it a string. You don't need to use a string as a variable. You can just give it a string. You can just give it the value of a string. So hello. So if this is equal to hello, if the contents of s1 are equal to hello, you can also ask that as well. We can also compare them alphabetically. If s1 is greater than s2, so this is comparison in an alphabetical fashion. If I don't know, s1 is whatever lesser than s2. So this is just going to do comparisons based on the alphabetical, in an alphabetical way. I don't really know what else is there to say about that. To basically add to the end of a string, we can use pushback. Simple as that, as before. So you can do addition. So s1 equals plus equals. No, that's just adding strings. Sorry, we can just do this. s3 dot push back. So we're adding it to s3. Okay, s3 is empty. We can add e. There we go. And down below, we can print s3 out. There we go. E has indeed been printed out onto the screen. You see, the string is to a very large extent different from the previous two types which we have processed here. You can also add strings. We can concatenate them. So you can type in s1 plus and equal or tra-la-la-la-la. Okay, so this is the same as me writing s1 plus tra-la-la. Instead of that, I am using a short version, so I'm just typing it in like this. You can also do this in a more complex fashion. For example, well, you can do it like this: std : string s4 equals s1 plus comma space plus s2. And you see s to the whatever is in s1, and we have hey, which is in s1. You will add a comma to it at the end, so it will be hey, comma, plus s2, which is hey, how is it going? That's it. We can even print it out onto the screen, just and run it. Okay, I seem to have a bit of an error here. What is the problem? Redeclaration of s4. Okay. Just give me s5. Why haven't you printed? Right. S5. Hey, tra-la-la, comma, hey, how is it going? We've already added tra-la-la to it in the previous one, in the previous line of code. So, well, not in the previous one, but actually, yes, in the previous one, we've added it there. But you can see how this works. Let me just go ahead and do it one more time. Analyze this and compare it to what we have done in these 3 lines of code and see how that has reflected the string itself, the string s5, how it has reflected in it. Now, there is another concept which is very important. You can, this is for user input. So if you're wondering how a user can input a whole sentence, well, to input a single string from a keyboard, and by this I mean only one word without spaces, you can do this as string S6, and we will leave it uninitialized there, and down below it will be std : cin, and naturally you would think that it's S5. Well, yeah, S6, sorry. Well, yes, it can go like this, but you can only input one word. Here, let me show you what I mean by it. Test, 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 but if I press a space and type in test again, sorry, I didn't create a printout. My bad. I mean, I did everything right, but I didn't create a printout, so you can't actually see what's going on. S6. Let's run the code again. Okay, so test blah tra. And you can see it has only taken test into consideration. Everything immediately as soon as I pressed space, it was no longer inputting this. So it was no longer concerned with this, so to say. It didn't take that into consideration. If you want to be able to input an entire line, well, then you would use this. std again, : get line, and it would be std : cin, S6. So in this fashion, you could actually, you have methods get line, and then you have arguments that are passed to it. In this fashion, you would be able to input an entire sentence, or pretty much how there aren't any significant limits to this. So it's like, I walked, let's type something like dance, run, party, jump, blah, blah, blah. And you can see all of these words are taken into consideration. They're placed into a string and printed out onto the screen. So before I wrap this tutorial up, once again, I repeat that string is probably the most important type here, if not the most important type. Please make sure that you understand it to the fullest of extents. Even with other programming languages, you're still going to need it. You're still going to, in all likelihood, you will use it. And it is a very important concept to grasp. Anyway, bid you farewell and hope to see you in the follow-up tutorial.